So today we're going to start our section of notes, which is about dividing polynomials. Now we have two techniques for dividing polynomials, and today we're going to focus mostly on long division. So long division is very similar to long division of just general numbers like you did when you first learned long division, but we're going to be talking about polynomials, which means it's going to include specific terms. So let's just kind of think about terminology. If we were asked to multiply, right, and I give you the polynomial, the binomials, x plus 2 times 3x minus 1, these are called binomial factors. X plus 2 is a factor, and 3x minus 1 are also factors. Right. Factors, or the product of factors, right, can create exactly what I just said. They create a product, which is another polynomial. And in this case, whether I use area box or columns, whatever method I want to use, I will get the polynomial product, 3x squared plus 5x minus 2. Well, what long division does is long division undoes the multiplication division concept. So what I want to start with is I want to start with a longer polynomial, and I want to divide by one of the factors to see if the other factor is also correct, or in some cases, what is the other factor. So let's look at how this is going to be written for us. So I would want you to divide, and I would want you to divide 3x squared plus 5x minus 2 by a factor of x plus 2. And so when I ask this question, I'm asking you a few different questions, really. What I'm asking you is, what is the result when I divide this polynomial by this polynomial? What is the resulting polynomial when I do this operation of division? The second question I want to know is x plus 2 a factor? And for x plus 2 to be a factor means I have to have no remainders. Right? It's very similar to questions of multiplying and dividing from when you first learn math facts. For example, if I want to know, is 2 a factor of 8, I'm thinking, is 2 times something going to give me 8? And if I can multiply 2 times something to get 8, then yes, 2 is a factor. Right? Just like if I asked you, is it possible if 3 times something will give me 8? If this does not happen, then 3 is not a factor. So we're thinking of along those terms when we're taking a polynomial and dividing it by a binomial factor. I want to know, is it possible for me to multiply x plus 2 times something to get this other polynomial with no remainders? So let's go through the process, and I'm choosing this one specifically because I know it already works. I already know that x plus 2 times 3x minus 1 will give me this polynomial. So I'm showing you the process working backwards, saying take the polynomial and divide by one of the factors to get the other factor, just to show you the process. So this right here, this polynomial factor, this is called my divisor. Right? I'm dividing by that value. So what we're going to do is we're going to take our divisor and we're going to put it on the outside, just like we do with other long division. And I'm going to write my polynomial on the inside. Now, when we do this, what we are asking ourselves is can I put something times x to give me 3x squared? I don't want to worry at the moment about the plus 2 sitting here. I just want to ask the question, can I multiply something times x to get 3x squared? And yes, I can. If I take the value of 3x and I multiply that times x, I will get 3x squared. Now I do need to, at this stage, consider the plus 2, because since there are two terms out here, I can't just multiply times the first one. I have to also multiply by the second. So let's do that multiplication. 3x squared is the first multiplication. 3x times 2 is a plus 6x. And I want to make sure that I line up the correct multiplication under each of the terms. Now when I do normal division, once we do the multiplying, we draw our line and we subtract. Now the thing with subtracting with polynomials is that I can't just subtract the first term, I need to subtract both terms. So what's going to happen is when I draw my line and I subtract, I need to subtract both terms, not just one. And so I do this thing to remind myself that it's both, is draw the line, change the sign. And what you're going to notice is that now, when I add, those terms cancel out. 5 minus 6 is a negative 1x. And just like normal multiplication and division, I normally drop down my next digit. I'm going to drop down my next term. And now the process starts all over again. I want to think to myself, is there something I can put here times x to give me a negative 1x? And again, there is. I think about the sign. All right. I need a negative x. No, I don't. I need a negative 1. I'm sorry. I just need a constant. I don't need the x because I already have my x. I just need a negative 1. Because if I had multiplied, I would have gotten something that I don't need. So 1, or negative 1 times x is a negative x. Negative 1 times 2 is a negative 2. And again, I need to subtract them both. So draw my line, change the sign. And then I'm going to add vertically. And it happens that all of these cancel out, and I'm left with no remainder. And so having no remainder is a good thing. Having no remainder means that, yes, I can take 3x minus 1 and x plus 2, and if I multiplied those together, I would get the polynomial on the inside. This polynomial here at the top, this is my remainder after division, or my result after division. And so a lot of times when we do our division, we want to know what happens when we divide it. What is my result? So we've got two separate questions being answered here. One is, what was my result after division? When I took this polynomial, divided by x plus 2, my result was 3x minus 1. The other question I am asking myself is, was the divisor a factor? When I get no remainder, then yes, x plus 2 is a factor. So when we are doing our polynomial long division, you have three pieces of information you need to show. You need to show the long division, showing the process that you are taking to find the result. You need to state the result after division and also what that means. That means that the divisor is or is not a factor. So we're going to go ahead and do a few more, ones where I don't necessarily know exactly what's going to happen, and polynomials that are longer also. So let's look at our second example. I'm going to take k cubed minus k squared minus k minus 2, and I want to divide this by k minus 2. So I'm changing the variable, and I'm changing slightly what I'm dividing by. That's okay. So remember that when we're doing this division, or when you're watching this video, sometimes you may need to watch it more than once to really understand what's happening. Right? You may need to pause it so that way you can get your notes down. But I want to take that polynomial and divide by k minus 2. And I want to start asking myself these questions. What can I multiply here times k to get the first term? So number-wise, I just need a coefficient of 1, but I need k squared to be able to multiply to get k cubed. So we're thinking about our rules of exponents and what times what gives us k cubed. So again, my second step, once I decide what I'm multiplying by, is to do the multiplication. So k cubed, k squared times a negative 2 is a negative 2k squared. Make sure you're lining up underneath the correct coefficients, the correct like terms. You're going to draw your line, change your sign, and then add vertically. So minus 1 plus 2 is a 1 with a k squared. Don't forget you need to have the correct variable and correct coefficients and the correct powers. Bring down my next term. Start the process all over again. Something here to multiply by k to get k squared. And I'm going to use a positive k. Make sure you put pluses and minuses in between each of the terms. Right. Now k times k is a k squared. K times a negative 2 is a negative 2k. Draw your line. Change your sign. Right. Now again, we're going to add vertically. Minus 1 plus 2 gives me a k. And bring down the negative 2. And so we need to go one more time. All right, we just brought down our last term. And so now my final piece here, and I want to be able to multiply by something times k to get a k. And what you're going to start noticing is this is going to go in descending order. I had a k squared, k to the first power, and the very last one that I'm going to use is going to be a constant. Right? You should always be going down in powers to where your last value is a constant. So when I multiply, I get k minus 2. Draw my line, change my sign. And again, both of these cancel out, and I'm left with 0 remainder. So again, what that means is that when I take this polynomial and divide by k minus 2, my result after division is the polynomial up here at the top. Right? It was k squared plus k plus 1. And because I have no remainder, then I can answer the question, was my divisor a factor? And yes, k minus 2 is a factor. So this is two examples of where my polynomial division resulted in the divisor being a factor. And so then in the next few examples, we are going to look at what happens when this is not a factor.